Over the past decade, the deteriorating state of our nation's infrastructure has gained increased attention. Great emphasis has been placed on aging bridges around the country due to several high-profile, catastrophic failures. But what about the unseen bridges of the transportation network? How can highway departments determine the state of both new and existing storm sewers and culverts? In many cases, out of sight is out of mind, until one of these culverts fail, causing damage to property or harm to people. The answer is post-installation inspection, or PII. PII has been gaining traction in several states across the country. Post-installation inspection delivers proof of proper installation and pipeline integrity before the structure is accepted. In order to inspect smaller diameter pipelines, special technology must be used to enter, inspect, and measure anomalies that might suggest improper installation or a failing structure. Post-installation inspection is required or suggested in all but 14 states across the country. The most basic PII equipment involves robot-mounted cameras for rigid pipe and mechanical mandrels for flexible pipe. To better understand the leading technology involved in the post-installation inspection of small diameter pipes, the Pennsylvania Concrete Pipe Association set up a demonstration in conjunction with Three Rivers Pipe Inspection. The demonstration uses a series of pre-cracked, reinforced concrete pipes to display the laser micrometer and video technology employed by many inspection crews across the country. Post-installation inspection should consist of a camera with lighting capable of showing the entire periphery of the pipeline interior. It should be as centered as possible, both vertically and horizontally, and must be able to pan and tilt around the circumference of the pipe. Video images should be clear and focused to avoid distortions that might prevent the viewer from properly evaluating the condition of the pipe. The strength of reinforced concrete pipe is stated as D load, which is the load in pounds per lineal foot per foot of internal diameter. Surface loading is checked on a 3-edge bearing machine by applying a line load at the top and supporting the pipe on 2 line supports at the bottom. The load is applied and measured until a 100th inch crack is produced in the pipe wall. The 100th inch crack is not an indication of failure, but rather an arbitrary measurement to confirm the design of the pipe. This test is the most severe loading to which any pipe will be subjected. There is no lateral support for the pipe, as provided under actual buried conditions, and the applied forces in the test are line loads. In this demonstration, the reinforced concrete pipe segments were pre-cracked and shimmed to hold the cracks at a certain width to help illustrate the crack measuring technology of laser micrometers. Several of these pipe segments were placed together with skewed alignment and other anomalies to illustrate deficiencies and how they appear during a video inspection. Post-installation inspections should be applied to all pipe materials. When evaluating flexible pipes, the reviewer should consider cracks and joint gaps, just as with reinforced concrete pipe. But they should also consider deflection, bulges, buckling, and tears. The final evaluation of PII data should be determined by an engineer. The crack measurements shown here utilize calibrated laser diodes that are projected on the pipe wall at a known distance apart. The camera operator then clicks on the diodes shown on his monitor and then on either side of the crack being measured. The computer relates the distance between the diode marks on the wall to the distance between clicks on either side of the crack. This relationship establishes a perspective and provides a measurement of the crack width. All national standards recognize cracks less than 1/100th of an inch do not require repair. Many allow cracks up to 5/100ths of an inch or the width of a dime. Cracks greater than 5/100th of an inch, but less than 1/10th of an inch, are acceptable provided the pipeline is not located in a corrosive environment. And it is generally accepted that cracks greater than 1/10th of an inch should be evaluated for repair or replacement. Video inspections are often used to determine the acceptance of installations, and during these inspections, cracks may be evident. All too often, an untrained inspector views a hairline crack to be a failure. However, cracks and other anomalies should be evaluated per national and local standards. Camera inspections without the use of laser technology often show distorted or magnified cracks due to the nature of optical equipment in a confined, wet, and poorly lit environment. As with all technology, the accuracy of camera inspections, even with laser micrometers, must be taken into consideration. Laser micrometer technology is currently only repeatably accurate for cracks larger than 5/100ths of an inch, or the width of a dime. But this technology is improving both in accuracy and precision on an almost daily basis. Despite the few limitations on accuracy and precision, post-installation inspections with laser video technology still provide the best option for owners and engineers looking to verify the proper installation of the pipelines and culverts on their projects.